Okay, so this is the next lesson in geometry. It's called parallel lines and transversals. Okay, so its first definition, this is review from earlier in the unit. It says, recall that lines that lie in the same plane, those are called coplanar lines. Okay, coplanar. Two lines that lie in the same plane, those are called coplanar. Okay. So this next definition, coplanar lines that do not intersect, those are called parallel lines. Two lines that lie in the same plane that do not intersect, those are called parallel lines. And this is the symbol for parallel lines. Looks like that. Okay. Coplanar lines that intersect to form right angles, those are called perpendicular lines. Since I'm writing lines, I'll put coplanar lines up here too. Okay, so perpendicular lines. And that's the symbol for perpendicular. It looks like an upside down T. Now those two we're going to use a lot throughout the year. So those two you definitely have to know. This next definition, we're not going to use too much. I think I'm going to talk about it today, and that might be it for the year. Okay, non-coplanar lines that are not parallel and do not intersect, those are called skew lines. Okay, skew lines, S-K-E-W. Okay, S-K-E-W. Now, we don't have a symbol for that one, though, okay? So here we go. Example 1, refer to the diagram at the right. Part A, name all planes that are parallel to plane ABG. Okay, plane ABG. Okay, so plane ABG, that is the top plane. Okay, the top plane is plane ABG. So what planes are parallel to the top plane? And it's going to be the bottom plane. Okay, the bottom plane is parallel to the top plane because they never intersect. So remember, when you name that plane, you can name it with 3 points, and the 3 points cannot be collinear. Okay, the 3 points cannot be in the same line. So for my answer, I'm going to say plane CDE. Okay, part B, name all segments that intersect segment CH. I'm going to color that in for a second just to help me see that, and I'll erase it before I do part C. Okay, so I'm just going to use a pencil, color this in so you see. Name all the segments that intersect that segment. Okay, we have a bunch of segments. So we have segment GH. Now, when we name that, we're going to use the symbol above it for segment. So segment GH like that. We have segment BC. Okay, so GH intersects that one. BC intersected it. What else do we got? We got segment EH. Segment EH. EH intersects CH. So does DC or CD. Either way. And you also got this segment drawn in. So this segment, CE or EC, intersects it. So CE we said. And it looks like that's everything. So we have GH, BC, we have EH, CD, and CE. Those are all the 5 segments that intersect this segment right here that I colored in, CH. So that's the answer for that one. Let's erase that before we do the next problem. Okay, part C. Name all segments that are parallel to segment EF. Okay, so I'm going to color in segment EF just to help us see the answer for this one. So parallel segments to that one. Well, we have AD. AD is never going to intersect EF, so we'll go with AD. GH is also parallel to it. And then, let's see, what else we got? We got BC. BC is parallel to it. So remember, parallel lines are like this. Like that's a parallel line to that. Those are parallel lines. Two lines that never intersect. Okay? So that looks like all the answers for that one. So we have segment AD. AD is never going to intersect EF. Same thing for GH right there, and same thing for BC right there. So it looks like that's it. Okay, part D. Name all segments that are skew to BG. So this is BG right there. Name all segments that are skew to BG. Okay, so above we have the definition for skew. Non-coplanar lines that are not parallel and do not intersect. So looking for non-coplanar lines with BG that are not parallel to BG and do not intersect BG. So the first one that comes to mind for me is AD. Segment AD is skew. AD is not in the same plane as BG. AD never intersects BG, and AD is not parallel to BG. So AD is one answer. Okay. Next one I can think of would be segment CD. Do that one next. CD is skew to BG. They're not in the same plane. They don't intersect, and they're not parallel. So CD. So we did AD and CD. The next segment I can think of would be CE. CE is skew to BG. They're not in the same plane. They don't intersect, and they're not parallel. So we got AD, we got CD, we got CE. Next, how about EF? EF is skewed to BG because EF and BG are not in the same plane. They don't intersect, and they're not parallel. And we have EH as well. Okay, EH. EH and BG are skew. They're not in the same plane. They don't intersect, and they're not parallel. And it looks like those are all the answers. So that's the end of that. Okay, so moving on to page 2. We have one definition at the top of the page. So in the drawing of the railroad crossing below, notice that the tracks, which are right here, represented by line T, they intersect the sides of the road, represented by lines M and N. A line that intersects two or more lines in a plane at different points is called a transversal. Transversal. Okay, so in this diagram right here, the railroad, that's called a transversal because it's intersecting two lines, two or more lines. Okay, example 2. We're going to be talking about transversals. So we have an airport right here. Okay, identify the sets of lines to which each given line is a transversal. So we're starting with line Q. Okay, and so you're going to see, what is line Q a transversal to? Okay, so again, this is line Q right here. What lines is line Q a transversal to? Okay. Now keep in mind, all these lines extend indefinitely in each direction. So you're looking for what lines does line Q intersect? Okay, so line Q intersects, let's see, it intersects line L, because line L is going to be extended. So when line L is extended, it intersects line Q. So I'll say line L. Line Q also is a transversal to line P, because line Q intersects line P. Line Q intersects line R, that's an R. Okay, and also line Q is going to intersect line N. Okay, again, these lines extend forever. So line Q is also going to intersect line N. And it looks like those are all the lines. So we have L, P, R, and N. Okay, so again, line Q intersects line L, you're going to extend it. It intersects line P, it intersects line R, because you're going to extend it, and it intersects line N. So those are all the lines that line Q is a transversal to. Okay. Part B, line M. What lines is line M a transversal to? What lines does line M intersect? And right away you can see it intersects lines L and P. Line M also intersects line N. And it's going to intersect line R when you extend it. Line R and line M will intersect. So also line R. My cursive R. Part C, line N. What does line N intersect? What is line N a transversal to? So right away you can see it intersects line L and line P. Line N is also a transversal to line M. And line R. Okay. And then the last part, line R. What is line R a transversal to? I think I put the wrong letter right there. Sorry about that. This should be a Q. I put the wrong letter. That should be a Q. I put R by mistake because line N intersects line Q. My bad. Okay. Line N intersects line Q, not line R. Line N and line R are parallel, so they don't intersect. So line N intersects these four lines. Line N intersects line L and P, and line N intersects M and Q, not R. Sorry about that. Okay. The last part, what lines does line R intersect? So that's line R right there. You can see right away it's going to intersect Q. Line R is going to intersect line M. When you extend line M, M intersects R. And line R intersects L and P when you extend those. Okay? So that's that page. And now the final page. Whenever you have two lines being intersected by a transversal, you have certain angle pairs formed. So for example, okay, these are the two lines being intersected by this transversal. Okay, so this is the transversal right here. These are the two lines being intersected. Line 3 and angle 3 and angle 6, those have a special name. Okay, they are inside the two lines being intersected, and they are on opposite sides of the transversal. So inside the two lines being intersected, opposite sides of the transversal, that's an example of alternate interior angles. That's what that's called. 3 and 6, those are called alternate interior angles. Alternate because they alternate what side of the transversal they're on. And interior because they're inside the two lines being intersected. 3 and 5, those are inside the two lines being intersected. And they're on the same side of the transversal. So those are called same side interior angles. You might also hear them referred to as consecutive interior angles, okay? So same side interior angles or consecutive interior angles is how you'll hear that called. Example, angle 1 and angle 8. Those are outside the two lines being intersected, and they are on opposite sides of the transversal. So those are called alternate exterior angles. Alternate exterior angles. Angle 4 and angle 8. If you think about these 4 angles as being one section, and think about these 4 angles as being another section. Angle 4 is in the bottom right of that section. Angle 8 is in the bottom right of that section. So those are called corresponding angles. And angle 1 and angle 7, those are both outside the parallel. Those are both outside the lines being intersected, and they're on the same side of the transversal. So those are called same side exterior angles. And I'll just put down the alternate name here. I'll put down consecutive. You might also hear them called consecutive exterior angles. And again, you might hear these called consecutive interior angles. Okay, example 3, refer to the diagram below. Identify each pair of angles as alternate interior, alternate exterior, corresponding, or same side interior. I use same side interior, or you could say consecutive interior. Okay. But the thing is, for this part right here, let me see, I need a piece of paper. Okay. This part right here, part A, angle 1, angle 7. What type of, what pair is that? So what you might want to do is, there's a lot going on in this diagram. You might want to ignore this, just cover it up with something, and just focus on what you have left. So angle 1, angle 7, those are both outside the lines being intersected, because A and B are the lines being intersected. L is the transversal. So 1 and 7 are outside, and they are on different sides of the transversal. So that's called alternate exterior angles. Okay, so that was alternate exterior angles. Okay, part B, angles 2 and 10. So this one is tricky. For this one, you're going to want to ignore this region right here. So let me, let's cover this up. Let's ignore that. Let's focus on the rest. Okay, 2 and 10. 2 is in the top right of this region. 10 is in the top right of this region. So those are called corresponding angles. Part C, 8 and 9. Let's cover this up. 8 and 9, those are inside the two lines being intersected, and they're on the same side of the transversal. So those are called same side interior angles. Next part, angle 3 and angle 12. So let's ignore this portion right there. 3 and 12, 3's in the bottom right, 12's in the bottom right. So those are called corresponding angles. Now the next lesson also involves these angles. So you really want to make sure you know what's corresponding, what's alternate exterior, what's alternate interior, and all these phrases. Okay, the next part, angle 4 and angle 10. Okay, so that one we're going to ignore this region. Okay, look at 4 and 10. 4 and 10, they're both inside the lines being intersected, and they're on opposite sides of the transversal, so alternate interior angles. And angle 6 and angle 11 for part F, cover that up. 6 and 11, they're both outside the lines being intersected, and they're on opposite sides of the transversal, so those are called alternate exterior angles. Okay, so again, this lesson is important. So you're going to need to know, especially the last page. Okay, you really want to make sure you know these 5 terms because you need them for the next lesson as well. And that's just an intro to parallel lines and transversals.